So hello everyone, welcome back to the video. So this is going to be statistics. I'm probably going to label it number 20, and it's going to cover what are called binomial distributions, and we're going to talk about the basics of binomial distributions first of all. The first thing that we want to know about a binomial distribution is what are they? How can I tell whether I have a binomial distribution or not? And so the first thing that I'm going to see is that what we want to do is define what a binomial experiment is. And to define that experiment, there are four conditions. And the reason we want to define this experiment is that at the end of these conditions, we're going to find out what the random variable is, and then we're going to be able to figure out the probability of each of those random variables. And once we do that, then we have a probability distribution. And because it's made from a binomial experiment, it'll be called a binomial distribution. So let's go to the four conditions. They're listed below for you on the screen. You might want to pause it and write it down, and then you can write notes as I say them. Okay, first condition is a binomial experiment has a fixed number of independent trials. So one binomial experiment would be, suppose I want to draw cards out of a deck of cards, and each time I draw a card out, I replace it back in the decks and reshuffle. What that does is that's what makes it independent, which, if you'll remember from our probability unit, independent means one thing happening does not affect the probability of the next thing happening. And so in general, binomial distributions have this kind of characteristic of with replacement, or they're from really large sets. And by a fixed number, we mean there's just a certain number of trials. So suppose I want to draw a card from a deck of cards, and I want to get heart. And what I do after I draw that card, I replace it in the deck. And I want to do this 5 times. So in other words, my fixed number of trials is 5. You can't do this infinitely. You have to stop at some point. Okay, condition 2. There are only 2 possible outcomes, and we call these outcomes either a success or a failure. So in my experiment of drawing cards, suppose I have a heart that I want to get, so I'm going to call that a success, and then anything else that I get out of the deck, a club, a spade, or a diamond, I'm going to call that a failure. So those would be my 2 possible outcomes. Now notice, a deck of cards has 4 suits, but by calling drawing a heart a success, then everything else becomes a failure, no matter even if they look different or not. The third condition is the probability of success will be the same for every trial. Now if I replace the card I pull out and put it back into the deck and reshuffle, then the probability of drawing a heart is going to be 13 out of 52, or 1/4 every time. And so that's the probability of success. The probability of failure then, of course, is 1 minus the probability of success, or whatever you have to add to the probability of success to get 1. And then finally, and this is the important one, the random variable counts the number of successes based on your binomial experiment. So in our card one, we're going to draw 5 cards, and the binomial distribution will count the number of successes. So let's make that distribution and go over some notation in the next slide. So first of all, the little example I was telling you, I want to draw a card from a normal deck of cards. I want to record the suit, and then I want to replace the card and shuffle, and then I want to repeat this 5 times. And then for our experiment, what we want to do is we want to call a success draw a heart, and we want to call a failure anything else. Alright? Oops, can't spell anything. And once we do that, now we're good. Now I know what a success is, I know what a failure is, I've made sure it's independent. There are only two outcomes, either I get a heart or I get everything else. And from what we had before, what's the probability of success? Well, that's going to be 13 out of 52, or 1/4. And the probability of failure is going to be then 3/4. So what are some of the notation that we have? Alright, so some of the notations we get are N. N is the number of trials. So in our experiment, N equals 5 because we did 5 trials. We pulled the card 5 times. Instead of writing probability of success, we make this a little easier and we just write small p to represent that. So I could have said 1/4 equals p. And instead of probability of failure, we just write Q for that. So I could have said, excuse me, let me fix that. The probability of failure equal to 3/4 is Q. So that's the notation. And then we want the random variable x to be the number of successes. Okay? So in 5 trials, how many successes can I get? Well, it turns out in 5 trials I could draw 0 hearts, or I could draw 1 heart, or 2 hearts, or 3 hearts, or 4 hearts, or all 5 cards could be hearts. Okay? And this is how your number of successes tends to work. It always starts at 0 and then you count up based on how many trials you have. And in your textbook they say it's 0 to n. Alright, since n is our number of trials. Okay, so that's our notation, and we know what the random variable is. So what we'd like to do is do a problem. So here's one example. Suppose you're a doctor and you have a new surgery technique for operating on some body part. And suppose, based on all your experience, you have found that you have a 95% chance of success every time you perform this surgery. Alright? So the question is this a binomial experiment? So what you have to figure out is you have to go through the 4 conditions to determine if this is a binomial experiment. So what are the 4 conditions? Well, the 4 conditions are, is there a fixed number of trials? And on first condition, you could say yes, because suppose I say I'm going to do this surgery once a month over the next year. So that would mean n equals 12. There's a fixed number of trials over the year because I do the surgery once a month for a year. Okay? And you'd have to say that, otherwise you're not really going to know. But in general, you limit the time period and you can make it fixed trials. Alright? Number 2, are there only 2 outcomes? And the answer is yes. Either the surgery is successful, so a successful surgery, or the surgery is unsuccessful. Alright? Which means that, person died on the operating table or something horrible like that. But anyway, again, there are 2 outcomes. So number 3, is the probability of success going to be the same? Well, each time as a doctor I go to get the surgery, there's a 95% chance that I'm going to be successful and only a 5% chance that I'll fail. And so in that case, I would say that the probability of success is always the same. So what's our random variables going to be? Well, our random variables are going to start at 0, count 1, 2, 3, etc., all the way up to 12 successful surgeries during the year. Okay, so I would say that yes, this is a binomial experiment. Is a binomial experiment. And then hence we'll be able to write it as a binomial distribution. So let me give you an example of one that is not a binomial experiment. Okay, so let's do it on the next page. So suppose you have a jar that has a bag, and so that bag contains 5 red marbles. Okay, it has 9 yellow marbles, and it will have 6 green marbles. So there's our bag that contains all the things that we wish it would contain. So we'll tie our bag. There we go. So now we have a bag that has the marbles in it. Now, suppose what we do is we're going to select 3 marbles from the jar. Select 3 marbles without replacement. So in other words, we're not going to put the marble back in there. Alright? And what we're going to say is the random variable represents the number of red marbles. Okay? So is this a binomial experiment? So what we have to do is we have to go through the 4 conditions. Alright? So number 1 condition was there were fixed number of trials. And the answer is yes, there were 3 trials. We were going to draw 3 trials out. But they also had to be independent. Are these going to be independent trials? And the answer is no. Why are they not independent? Because once I draw out a marble, I no longer have the same amount of marbles in there, so the probabilities change. So that's a reason why this fails to be a binomial experiment. Now let me go on. Are there 2 outcomes? And the answer is yes, there are 2 outcomes. The 2 outcomes are you draw a red marble or you don't draw a red marble. So success is a red marble and failure is a yellow or green marble. So that's fine. So this one would be okay. Step 3, is the probability of success the same? And this would be a failure because on the first draw it would be 5 out of 20 would be the probability of success, but on the second draw, if we were successful or not successful, it could be 5 out of 20 or 4 out of 19 if we had gotten a red on the first one. And right there it shows it's not independent. So that's why we fail the independence condition. Alright, excuse me, it should be 5 out of 19 here, or 4 out of 19. And then the random variable counts the number of successful trials. That's okay because we'd have the random variable is 0, 1, 2, or 3 successful trials. Okay, so that's all you need to know for this first assignment, is how to decide whether you have a binomial experiment or not. Okay, thanks.